Austin, hi, happy new year. Good to see everybody. Sorry I'm not there. It's not fun being here and dealing with the COVID virus, but hey, it was bound to happen. Anyway, let's get in the swing of things. Everything should look like it did before. If we click on video notes and assignments, you will notice this Unit 5 packet has been updated. You'll notice that we have the assignments already linked and all of them are IXL assignments. Remember, you can find assignments here in the video note assignments in addition to the assignment page here, there, and make sure you have the third 9 weeks already highlighted in your drop down menu, and then all of your IXLs for this Unit 5 appear. And no, it's not a mistake that there are two 5.2s and two 5.4s. They're different IXLs, but they're done on the same day, which is why they're called the same thing. Okay, so let's go back to the home page. Let's click on the calendar this time, and let's go to today's date. All right, so learning objective, welcome back, fam. I have missed you all, and I am sad that I am not here today, as I have the plague. Yeah, my brother calls it the plague, so I thought it was funny. So here's what we're gonna do. I would like you to click on number 1, discussion board question. Be ready to stand up and say one thing about your break. Remember, I'm at home and I'm not coming to school till next Monday. So what that means is I want to hear about your break, because by next Monday, nobody will care about the break anymore. And I would like to know about you and what happened this past 14 days. So click the discussion board. Go ahead and it says on this discussion board, write about your entire break. It must consist of 3 or more sentences, guys. I don't know how many I have in my example. I know it's at least 10 or 12. I didn't count, but I'm just guessing. So read my example. And then, y'all, I put together a PowerPoint of what did I do over this break. And as you'll read, I was in quarantine. I didn't do much, but for what I did do, it's super fun to watch. It's all about my children. So who wouldn't have fun watching that? And once you finish, you're going to go ahead and reply, and you're going to type your stuff. Now that's to reply to me. So if you want to comment on mine, I would love you guys commenting on my story. On your screen, when you click it, you're going to have a place where you're going to type your story. You're going to hit submit. And then once you hit submit, you'll be able to go and read other people's so you can comment. All right. So let me cancel that. Let me go back to our calendar daily agenda. Okay, now it says, read the cover of Unit 5 packet, turn to a classmate and talk about what you think you understand. So let's do that. Unit 5 packet, it's called Systems of Linear Equations or Inequalities. Here is not a system, here's just one inequality. Remember when we left in the fall, we were drawing lines on a graph, and that's all we were doing. So today, we're going to be drawing lines on a graph. We're going to be talking about greater than, less than, equal to. So in this unit, you're going to be graphing a line that's shaded up or down, or you might be graphing a system, where on this line it's shaded on this side, and on that line it's shaded on that side, and where the two colors overlap is the solution to the system. Okay, so our next step 2 or 3 said read the teaks. So this unit has only 3 teaks in it, y'all. Seriously, the shortest teaks we will have read. Okay, shortest ever. So there's 3 teaks, A2H, A3D, and A3H. A2H is the most popular STAR questions. It's been on every single STAR test, and there's 2 questions on every test for A2H. A3D has 1 question, give or take it what year, and A3H is the least tested out of all 3 teaks. It's been tested once in the last 6 years with 1 question. So it would probably be this year that you're going to get 1 question for sure. Okay, let's go back, and it says we're going to work on page 2, which is a recap from semester 1 for unit 5 tech success. And guys, you can work with a partner on this. So let's go to our packet. My little star at the bottom of page 1, it says IXL will be a strong source in this unit. Please make sure you are completing your IXL assignment each day, and if you need help, ask your peer, your teacher, and attend tutorials. Your homework grades, guys, are going to be the IXL assignments. So the good thing, it's all online and you don't have to do math on paper. The bad thing is it's all online and you don't do math on paper. Okay, so there's pros and cons to both. And I think this section really is nice to do on IXL, but we do have at the back of our packet all of the questions for the STAR that I really and truly want you guys to take the time to work through when I assign those STAR questions throughout this unit. Okay, so here's our recap, semester 1 for unit 5 success. All right, I want you to press pause. I want you and your partner to work together and see what you can come up with and do on your own. Then unpause me and I will have shown how to do each of these 2 questions. These are all from the fall. So this is something that I think we should all remember. And if you don't remember, at least be like, oh yeah, no, that's the B. And oh yeah, M is rise over run. Oh yeah, that's part of that. So that's what I want y'all to do. Press pause, and then I want you to listen and make sure you understand, okay? Press pause. Okay, unpause. Here we go. Welcome back. Write the equation for this graph. Okay, first thing it says is to highlight the y-intercept. Let's do it. Remember, the y-intercept is where it crosses the y-axis. So in this case, it's the number 2. So our B is 2. Now we're gonna mark the perfect points and find the slope. So remember, the perfect points are where the line crosses the graph perfectly. So right there, right there, right there, right there. I think that's it. So there's 4 perfect points. Now we're going to count the boxes and the spaces between each of those points. So we like to start with the left side and finish with the right side. So here we go. Rising up 1, up 2, up 3. So 3 up and 1 over. So let's see if it continues. Up 1, up 2, up 3, 1 over. Up 1, up 2, up 3, 1 over. Okay, so 3 over 1 is our slope, and 3 divided by 1 is 3. So to write the equation in y equals mx plus b form, we're going to use the b and the m, and we're done. Y equals 3x plus 2. That would be the equation of the line. So high five your partner if you guys got those first 3 questions. All right, now part 2 is rewriting the equation and then graphing. So we're going to have to practice graphing on this example, whereas the first example, we had to read the graph and write the equation. So they're a little bit different, but they go hand in hand, okay? So remember when Coach Hughes would tell you, box the Y, and let's try to do what we were doing last year, where you beat the video. Beat the video, figure it out before I figure it out. We box the Y, we move the X, and we move it by doing the opposite. Since it is positive right now, I'm going to do the opposite and subtract it. We don't subtract it under the negative 15 because they're not the same term. They're different terms. I'm gonna move myself to the middle, and then I don't have to keep looking over there. Okay, box the Y, move the X. What did I say next, y'all? That's right, divide, divide, divide. And that's what I'm gonna do now. Divide, divide, divide. All right, now let's see what we get. 5 divided by 5 crosses out, and we get Y. Negative 15 divided by 5 is negative 3. Negative 2x divided by 5 is negative 2x divided by 5. We're done. We have solved for Y. This is in our graphing form. I'm going to grab that highlighter. I'm going to highlight the y-intercept. That's the first point that goes on my graph. And now I'm ready to graph my rise over my run. So in this case, we have a negative 3 y-intercept, and our slope is negative 2 over 5. So our B is negative 3, and our M is negative 2 over 5. So I like to do rising over running. So since the top number is a negative 2, I'm going to go down 2. The bottom number is positive 5. I'm going to go over 5 and put a point. So what did I do? I went down 2, which is negative, and over 5, which is positive. Now I'm going to go backwards. I'm going to go up 2, but I'm going to go negative to the left 5. So now I'm going to go up 2 and to the left 5 spaces. So let me show you how I did that. Up 2 and left 1, 2, 3, 4, 5. Now you can erase that part so it doesn't look so messy. And now you can connect your 3 points. So in this example, we only get 3 perfect points on the graph. And you have your line y equals negative 3 minus 2 over 5x. Cool. All right, last comment on here. It says, what do you remember about an inequality? And you should have filled that out. Whatever you remember about it, you might have already looked on the front page of the packet and you remember something because you looked at it and you just write it down. I don't know what you remember, but it should be written down at this point. Okay. Here we go. Introduction to linear inequalities. So on one side, we have equations. On the other side, we have inequalities. All right, and they're a little bit different. Actually, they're a lot of bit different. Let's talk about the left side. Represent a relationship of equality between 2 variables. Remember, equality means they're equal because we're equal. So the question says, Tomas earns exactly $8 for every hour he works plus a $20 base pay fee. So the equation would be Tomas earns, that's Y, exactly, that's equals $8 per hour is 8x, plus would be a plus sign, $20 base pay plus 20. So that's how they come up with that equation. On the linear inequality, though, sounds pretty similar. Tomas earns, this time it's at least $8 for every hour he works, plus a $20 base pay. So again, we have Tomas earns, that's the variable y. At least means equal to or more. Write that down. Equal to or more. And that's tricky because at least, you hear the word least and you think less, but this is opposite. I want at least 5 cookies in my hand. I better have 5 or more cookies in my hand. At least is equal to or more. So that is why it's y is greater than or equal to 8x plus 20. All right, let's move on. What happens if we substitute wherever we see the x for these numbers? Let's do it. What is 8 times 3 plus 20? Well, that's going to equal the y answer. So 24 plus 20 is 44. That equals y. What about the 7? 8 times 7 plus 20. Well, 8 times 7 is 56. And 56 plus 20 is 76. That equals your y. For the 10, you'll do $8 an hour times 10 hours. That's 80 bucks, and 80 plus 20 is 100 bucks. Okay, so the answer here is 44, 76, and 100 when our value for x is 3, 7, and 10. You know I'm a math teacher, so I'm going to throw out these words. When the domain is 3, 7, and 10, the range is 44, 76, and 100. Okay, so let's see what happens when we work the same numbers, but now we have an inequality. Now, the good thing is I've already done the math over there. So when it says 8x plus 20, and it's a 3, I know I'm going to get 44. But it says y is greater than or equal to 44. So it could be equal to 44. It could be greater than 44. So any number greater than 44. Y is greater than or equal to 44. All right, well, 45, 46, 47, 52, 76, and so on. So there's many answers. For the 7, I already know it's equal to 76. So y is greater than or equal to 76. 77, 78, $79.30, decimals, all that's included. Same thing for 100. Y is greater than or equal to 100. 100, 110, 300, numbers bigger than 100 or equal to 100. Okay, so in our left example, one output for every input. These are the only 3 answers. But for our inequality, we have many possible outputs for each x, right? Because it could be 44, it could be 45, and so on. It could be 76, it could be 80. It could be 100, it could be 200. There's more than one answer. All right, so that's the difference. Let's talk about what a solution set is. What's a solution set? A solution set of a linear inequality is all ordered pairs that satisfy the inequalities. Okay, right now that doesn't make sense, but remember in ordered pairs in x comma y. So we're going to have lots of answers with x comma y's. So let's look at example 1. Think of at least 5 pairs of numbers whose sum is less than 10. Write them as ordered pairs. Okay. I'm thinking of summing something, which is adding. I'm adding 2 numbers together. I don't know this number, I don't know that number, but I want it less than 10. So this is my inequality that I would write. Some number plus a different number has to be less than 10. Write them as ordered pairs. Okay. If I want X to be 5, what could Y be? 5 plus Y is less than 10. We minus 5 from both sides. Well, I would have to pick a Y less than 5. Okay. What about 2? Is 5 plus 2 less than 10? Yes, it is. What if I picked X to be 3? What could Y be? Well, 3 plus Y is less than 10. When I minus 3 to both sides, the answer says Y is any number less than 7. As long as Y is less than 7, you're going to satisfy this number plus that number is less than 10. So I'm going to pick 6. Is 3 plus 6 less than 10? Sure is. All right, so you get the deal. Now think of another answer. Let's pick 1 and 2, because 1 plus 2 is less than 10. What about 7 and 3? Would 7 and 3 be less than 10? Nope. 7 and 3 is equal to 10. This inequality wants less than 10. 7 and 3 would not be a solution. What about 7 and 2? Yes, 7 plus 2 is 9, and 9 is less than 10. That would be an option. 5 and 4 is also 9, and that is less than 10. So I'm writing them as ordered pairs. So your job is to try number 1 and write them as ordered pairs. So here's my inequality. And then here are my 5 possible ordered pairs. And there's many more, I just didn't have, it only asked for 5. All right, example 2. You have 20 bucks in your pocket. Oh yeah. Bags of Takis cost $1.50 each, and packs of gum only cost 99 cents. How many of each could you buy? Think of 5 combinations. So if I have 20 bucks, do I have more than 20 bucks? No, I only have 20. So my Takis and my gum, whatever I decide to buy, has to add up to be less than 20 bucks or I can't buy it. So we're going to let Takis represent an X. We're going to let gum represent Y. And we're going to write an inequality because Takis is $1.50 per bag. So times X. Gum is 99 cents per pack, and I have to pay all of that money added together has to be less than or equal to 20 bucks. That's all I got in my pocket. All right, so there we have it. Here we go. So think of 5 combinations. Again, pick an X value. I'm gonna buy 2 bags of Takis. Let's do that. How many packs of gum could I buy? So $1.50 times 2 bags of Takis would be $3. And then I'm going to minus 3 to both sides. And then I'd have 99 cents is less than or equal to 17. All right, so then if you feel like, what's 99 cents going into $17? Just do a quick Desmos. I have $17, I'm dividing it by 99 cents. I can buy 17.17 packs of gum, but we can't buy 0.17 pack of gum. I could buy less than or equal to 17 packs. So 17.17. So I could buy 2 Takis. I could buy 16 packs of gum, and I'm going to have some money left over. Okay. I could buy 5 bags of Takis. So I'm going to do $1.50 times 5 bags is $7.50. Now I'm going to take my $20 minus $7.50 is $12.50 left over. I'm going to divide that by 99 cents. I could buy 12 packs of gum if I bought 5 bags of Takis or less. So I could buy 12 packs of gum or less. All right, so you keep doing that, you're going to get 5 combinations. All right. If you notice, let's see. Yeah, Desmos won't let you graph an inequality sign. Look, guys, I have to put equals. I've made it mad. So let me put y equals. If I put y equals, oh, it now wants to do a triangle because it says, why are you stopping? Anyway, whatever, Trevor. You try number 2. You're saving up for a new set of AirPods. They're $129. You earn $15 per hour babysitting or $20 per yard mowed. How many hours do you need to work for each to earn enough to buy the AirPods? Think of at least 5 combinations. So you're going to write your inequality like I have. Then you're going to think of your combinations. All right. It says, what if I'm given an inequality and I'm asked if an ordered pair is a solution? So it kind of goes backwards. We're given the statement. They're asking us, is this a combination that works? Okay, so the name of the game here is substitution. That's all you got to do in this case is substitution. So the question here is, remember that the first number in each point is x, the second number is y. We're going to take this inequality and substitute in a -2 and a +3. So 3 is greater than 1/2 times x. X is -2 plus 3. Half of -2 is -1. -1 plus 3 is +2. 3 is greater than 2. Ask yourself, what is it? What's the hint? Take your highlighter. Is this true? Is this true? Is 3 greater than 2? Why, yes, it is. Yes, this is true. Ew, that is really ugly. That is ugly. Let's erase everything. Yes, this is true. Therefore, see, you're learning a lot of things new, and it's only January 5th. This right here means therefore in math. Therefore is 3 dots like a triangle. Therefore, -2, 3 is a solution. It either is or it isn't. Cool. Moving on. You try now. Press pause. Take your inequality. Take your x and take your y. Substitute it in. Ask yourself, is this true? Press pause. Okay, let's try. 4 is less than or equal to 2 times 1 plus 5. Is that true? Let's do it. 2 times 1 is 2. 2 plus 5 is 7. Is 4 less than or equal to 7? Is this true? Yes, 4 is less than or equal to 7. So here's where people get confused. Yes, 4 is less than 7. Is 4 equal to 7? 4 is less than 7, yes. Is 4 equal to 7? No, but this is not an either or. I mean, this is an either or. 4 is less than 7. That's all it has to be. This is true. Because 4 is less than 7. It's not equal, but it is less. That means 1 comma 4 is a solution. Booyah! Let's look at example 4. Is 4 comma 6 a solution to this inequality? All right, this is in standard form because x and y are together. They're not apart. Here we go. X comma y. Substitute it in just like we did a minute ago. 3 times 4 minus 2 times 6. Is this true? Is it greater than 4? Let's see. 12 minus another 12 is 0. Is 0 greater than 4? Ask yourself, is this true? Nope. 0 is not greater than 4. Therefore, 4 comma 6 is not a solution. All right, you try number 4. Is this true? Try number 4 with a partner. After you and your partner agree on it, ask another group what they thought. If all 4 of you agree, you probably got it right. Okay? Hopefully you've already pressed pause. If you keep on going, that means you didn't listen to instructions, guys. This is a new year. We're turning over a new leaf. Okay. Last example, it says graphing a linear inequality exploration. It says circle all the pairs that are solutions to the inequality. Cross out any ordered pairs that are not solutions to the inequality. I think this should be that. Okay, here we go. Does 2 comma 1 work? So 2 and 1. So that's now a -2. Is -2 plus 2 is 0. Is 1 greater than 0? Is 1 greater than 0? Yes, it is. All right. Next, 3 and 4. So 4 is 4 greater than -3 plus 2. Well, -3 plus 2 is -1. Is 4 greater than -1? Yes, it is. Oopsies. What am I doing? All right, let's try our next question. I'm really thirsty right now. All I have is hot tea and it's cold now. And who wants to drink cold, hot tea, not cold? Okay. Now we have -2 comma 1. So we'll put our 1 there. We have a -2. Remember, x is -2 and x is already negative in the problem. So you have a -2, which really makes that a +2. So a +2 plus 2 is 4. Is 1 greater than 4? No, it's not. All right. Y'all see how this is happening here? Okay, for the fourth point, we have a -1. Is that greater than a -1 plus 2? A -1 plus 2 is 1. Is a -1 greater than a +1? No, it is not. All right, what about 0, 0? I have 0 is greater than a 0 plus 2. 0 plus 2 is 2. Is 0 greater than 2? No, it is not. Hope y'all are getting the hang of this. All right, for our next point, we have y as a 3. Is 3 greater than a -1 plus 2? A negative means a positive. Is a +1 plus 2? Yep, that's equal to 3. Is 3 greater than 3? Nope, they're equal. So you can't use a greater than sign when it's equal. Has to be a greater or an equal. This is just greater. So 3 is not greater than 3. Next. 2, 0. Is 0 greater than a -2 plus 2? -2 plus 2 is 0. Is 0 greater than a 0? Nope. Cross that out. Now let's go to 1, 2. All right. We'll put 2 here. Is 2 greater than a -1 plus 2? -1 plus 2 is 1. Is 2 greater than 1? Yes, it is. 4, 2. Is 2 greater than a -4 plus 2? -4 plus 2 is a -2. Is 2 greater than a -2? Yes, it is. All right, 5, 0. Is 0 greater than a -5 plus 2? A -5 plus 2 is a -3. Is 0 greater than a -3? Yes, it is. Last one. -1, 5. Is 5 greater than a -1 plus 2? Remember, when x is negative and you substitute it into a number that's already negative, it comes to negative, which makes it a positive. 1 plus 2 is 3. Is 5 greater than 3? Yes, it is. We've got 6 good points, 5 bad points. Can you think of any more points that are solutions? I bet I could if I sat here and thought about it. Yeah, like -4, 5. +4, 5. Because when you substitute in a 4 right there, is 5 greater than a negative? But then I'm substituting in a 4 plus 2. -4 plus 2 is -2. Is 5 greater than a -2? Yes, it is. Can you think of any more points that are not solutions? Double challenge. Come on now, people. Okay. I'm sure I could think of more. Yes. Let's get to the next thing. Y'all are probably falling asleep by now. Graph each point from part 1 that is a solution and put an X for each point that is not. Okay, goodness gracious. 2, 1. 3, 4. -2, up 1. 1, -1. 0, 0. -1, 3. 2, 0. 1, 2, 4, 2, 5, 0, -1, 5. I said 4, 5. Can you draw a line on the graph that separates the solutions from the non-solutions? I'm going to say yes, like that. What would the slope and the y-intercept be? Well, I'd have to say, oh, okay, that looks like 2.5. So y equals something plus 2.5. I don't know. It's negative because it goes down. That looks like it could work. So 1, 2, 3, 1, 2, 3. So maybe it's down 3.5 over 3. And then I would like type that in the Desmos. And this is all just make it up. So the other thing I could do is actually graph the line that it told me to graph here. Let me do that in pink. This line says start at +2. This line says go down -1 over 1. Uh-oh. Is 2, 0? Oh, yeah. Okay. Okay. All right. And then what you're going to learn next class is a greater than sign is a dotted line. So you'll notice that some of these solid dots are on X's because this is a dotted line, and greater than means shade above. And that is where all of our solid dots were located. Thanks for tuning in. This is day, I don't know, 4 of COVID. And so I am doing a lot better than day 1. I scratched my nose during this lesson like 1,000 times. I don't know if you noticed, but I did, and it was really frustrating. Now I'm scratching my lip. My voice is thirsty, but I am truly doing better than I was 4 days ago. Anyway, I'm excited to see you guys in person. I'll see y'all next week. Please work on your IXL and finish up what you need to. Okay, bye.